This is shocking. Dust from a giant asteroid collision in space caused an ancient ice age here on our Earth. This is on phys.org by the Field Museum. You could imagine how far all this dust went in order to reach us and cause the chaos that happened to our Earth. The illustration of a giant asteroid collision in outer space, producing the dust that led to an ice age on Earth. Amazing. About 466 million years ago, long before the age of the dinosaurs, the Earth froze. The seas began to ice over at the Earth's poles, and the new range of temperatures around the planet set the stage for a boom of new species evolving. The cause of the ice age was a mystery until now. A new study in Science Advances argues that the ice age was caused by global cooling triggered by extra dust in the atmosphere from a giant asteroid collision in outer space. There's always a lot of dust from outer space floating down to Earth, little bits of asteroids and comets, but this dust is normally only a tiny fraction of the other dust in our atmosphere, such as volcanic ash, dust from deserts and sea salt. But when a 93-mile-wide asteroid between Mars and Jupiter broke apart 466 million years ago, 93 mile wide, it created way more dust than usual. Normally, Earth gains about 40,000 tons of extraterrestrial material every year. I never even knew that. 40,000 tons of space material every year. That's mind-blowing. It's astonishing. This is what Philip Heck, curator of the Field Museum, associate professor at University of Chicago, one of the paper's authors, says. Imagine multiplying that by a factor of 1,000 or even 10,000. To contextualize that, in a typical year, 1,000 semi-trucks worth of interplanetary dust fall to Earth. In the couple million years following the collision, it'll be more like 10 million semis. He explains, our hypothesis is that the large amounts of extraterrestrial dust over a time frame of at least 2 million years played an important role in changing the climate on Earth, contributing to cooling, he says. 2 million years. Our results show that for the first time that such dust at times has cooled Earth dramatically, says Birger Schmitz of Sweden's Lund University, the study's lead author and a research associate at the Field Museum. He says our studies can give a more detailed, empirical-based understanding of how this works, and this in turn can be used to evaluate if model simulations are realistic. To figure it out, researchers looked for traces of space dust in 466 million-year-old rocks and compared it to tiny micrometeorites from Antarctica as a reference. He said, we studied extraterrestrial matter, meteorites and micrometeorites in the sedimentary record of Earth, meaning rocks that were once seafloor, Heck said, and then we extracted the extraterrestrial material to discover what it was and where it came from. Extracting the extraterrestrial material, the tiny meteorites and bits of dust from outer space, it involves taking the ancient rock and treating it with acid that eats away the stone and leaves the space stuff. The team then analyzed the chemical makeup of the remaining dust. The team also analyzed rocks from the ancient seafloor and looked for elements that rarely appear in Earth rocks and for isotopes, different forms of atoms that show hallmarks of coming from outer space. For instance, helium atoms normally have 2 protons, 2 neutrons, and 2 electrons, but some that are shot out of the sun and into space are missing a neutron. The presence of these special helium isotopes, along with rare metals often found in asteroids, proves that the dust originated from space and not from Earth. Now, if you take a look at the picture of the cliffs made of sedimentary rock that was once ancient seabed, the gray horizontal line in the rock shows where the dust from the asteroid collision fell. This is again from the Field Museum by Philip Heck. So that's astonishing. I'm sure it's worldwide. It's a worldwide sediment, a deposit. So other scientists had already established that our planet was undergoing an ice age around this time. The amount of water in the Earth's oceans influenced the way that rocks on the seabed form, and the rocks from this time period show signs of shallower oceans, a hint that some of the Earth's water was trapped in glaciers and sea ice. Schmidt and his colleagues are the first to show that this ice age syncs up with the extra dust in the atmosphere. He says, the timing appears to be perfect. The extra dust in the atmosphere helps explain the ice age. By filtering out sunlight, the dust would have caused global cooling. Since the dust floated down to Earth over at least 2 million years, the cooling was gradual enough for life to adapt and even benefit from the changes. An explosion of new species evolved as creatures adapted for survival in regions with different temperatures. Heck notes that while this period of global cooling proved beneficial to life on Earth, fast-paced climate change can be catastrophic. In the global cooling we studied, we're talking about timescales of millions of years. It's very different from climate change caused by the meteorite 65 million years ago that killed the dinosaurs, and is different from the global warming today. This global cooling was a gentle nudge. There was less stress. It's tempting to think that today's global warming could be solved by replicating the dust shower that triggered global cooling 466 million years ago, but Heck says he would be cautious. Quote, geoengineering proposals should be evaluated very critically and very carefully, because if something goes wrong, things could become worse than before. While Heck is not convinced that we've found the solution to climate change, he says it's a good idea for us to be thinking along these lines. Quote, we're experiencing global warming, it's undeniable, Heck says, and we need to think about how we can prevent catastrophic consequences or minimize them. Any idea that's reasonable should be explored. So this is from Field Museum by B. Schmitz and Company. An extraterrestrial trigger for the mid-Ordovician Ice Age was the title of the study. Dust from the breakup of L-chondrite parent body. Science Advances, 2019. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.